This is a review lesson covering what we've learned the last few days about working with exponents and roots. So this is going to include working with fractional exponents and a little bit of the working with different kinds of roots like fifth root, fourth root. There is not a complete set of the root type problems. So if you're studying for the quiz on Monday, you're going to want to go back and make sure you also try to do the problems from day 5 and day 6 homework and watch those videos. Make sure you can do all of the problems on the day 5 and day 6 homework in addition to these problems, because there's some types of problems that are missing. All right, let's get started. All right, because this is a review lesson and because this is the longest homework I've ever given, I'm going to be going through these problems quickly. So again, if I'm going too fast, well, I guess you can always pause and rewatch, but I gave a more thorough explanation on previous homeworks when we did it for the first time. So you could look back at day 5, day 6, and day 7. I went slower. All right, so the deal is this. If the bases are the same, you can add or subtract the exponent. So here the bases are the same, so we can add the exponent. So I'm doing 5 over 3 plus 1 over 3. So 5 over 3 plus 1 over 3 is 6 over 3. And so that is 3 to the second power, because 6 divided by 3 is 2. And that is 9. So the answer number 1 is 9. Number 2, here we have a power raised to a power, and that's when we multiply. So this is going to be 5. Now 2 times 1 is 2. 3 times 2 is 6. So this is 5 to the 2 over 6 power. Of course, we'll go ahead and reduce this. All right, 2 over 6 reduces down to 1 over 3. All right, looking at number 3. Look, if the exponents are the same, you can go ahead and multiply the bases. So we're going to go ahead and do 4 times 64. And you will not be allowed to use a TI-30 XS multiview. So you will be allowed to use a 4-function calculator though. So you'll notice I'm only using the, you won't see me doing anything other than adding, subtracting, multiplying, and dividing. So I have 256. So that means this is 256 to the 1/4 power. We know that 1/4 power is the same thing as the 4th root. So the 4th root of 256. All right, if we look at the table, the 4th root of 256 is 4. So this is going to simply be 4. So that's the answer number 3. Okay, on number 4, I see that we have a negative exponent. All right, if something has a negative exponent, it is on the wrong side of the fraction. So when this comes up, then I find that I have 36 to the positive 1/2 power up here. All right, and again, 1/2 power is the same thing as square root. So square root of 36 is 6. So that's the answer number 4. Number 5, notice that the bases are the same. If the bases are the same, I can subtract these exponents. When you divide, you subtract. So this will be 7 to the 1/5 minus 3/5 power. 1 minus 3 is negative 2. So this will be 7 to the negative 2 over 5 power. Now, because this has a negative exponent, that means it is on the wrong side of this invisible fraction line. So I have to take this expression and drop it down. If I do that, then what I have is 1 over 7 to the 2/5 power. And that will be the answer to number 5. All right, let's look at number 6. Notice that the exponents are the same. If the exponents are the same, you can do the division. So I'm going to do 70 divided by 14. And that is 5. So for that reason, I'm going to have 5 to the 1/3 power. And that's it. That's the answer to number 6. All right, how about number 7? Okay, the bases are the same inside of here. So if the bases are the same, what, the 12th power? I don't think that was supposed to be the 12th power. Since the bases are the same, we're going to add these exponents. So this will be 2 to the, and we're going to do 1/4 plus 1/3. Oh, I see what's happening. It'll be okay. So I'm doing 1/4 plus 1/3, and I've still got the 12th power out there. So look, I'm going to do this addition off to the side so we can all see what's going on. If I do 1/4 plus 1/3, I need those denominators to be the same. So here, if I multiply this by 3, I'll get 12. And if I multiply this by 4, I'll get 12. I need those like denominators. So this is going to become 3 over 12 plus 4 over 12. And 3/12 plus 4/12 is 7/12. All right, so let's remember that's how you add fractions. So that's what's going to happen here. So that's why I'm going to have inside of my parentheses, all right, I will have 2 to the 7 over 12 power. Okay, to the 12th power. So of course, that 7 over 12 in there came from this calculation. Now, the easiest thing to do, rather than multiplying 7 by 12 and then dividing, the easiest thing to do is just recognize that these 12s will just cancel out. This one's low, this one's high, they cancel. So this is going to be 2 to the 7th power. Okay, and you can leave it like that. I mean, the 7th power is not even on our chart. So normally we would do it out, but our chart only goes to the 5th power. So I would accept 2 to the 7th power as an answer. Okay? Number 8. Now, the powers are the same, so if 5 divided evenly into 8, I could do it. But 5 doesn't go into 8, so there's really nothing I can do with that. So I'm going to go ahead and just multiply here. All right, a power to a power is where you multiply. So this would be 5 to the -1 power and over 8 to the -1 power. Now, if you're not 100% sure where I'm getting the -1 from, here's what I'm doing. All right, when we multiply 2 times -1/2, this is what's happening. We have 2 times -1 over 2. Now this 2 is really like 2 over 1. Okay, so when you multiply, you just multiply straight across. So this is -2 over +2. So that's where we're getting the -1 from. All right, and it's the same thing for both of these. Now, both of these have a negative power. Now, if you have a negative exponent, that means you are on the wrong side of the fraction. So this is going to have to go up, and this is going to have to go down. Okay? So if you do that, then you will wind up with 8 in the top and 5 in the bottom. And you got the 1 power, but we don't really need to put the 1. So 8/5 would be the answer. All right, looking at number 9. Let's see. Okay, all right, this one's going to take a tiny bit of extra work. The exponents are not the same, nor are the bases the same. All right, so this one is slightly different than any problem we've ever done before. So watch this very carefully, as I don't see any way around this. Since the exponents are the same and nor are the bases the same, what we can do is we can make all the bases be the same. Because if you look at it, every single one of these things are on the power of 2. I'm sorry, not the power of 2. They're on the base 2 row. Okay, see, I've got 4, 8, 16, 32. All right, are all powers of 2. Now, if I look at this, 4, 16, 32, those are all powers of 2. So I can rewrite each of these as a power of 2. So this is what I'm saying. We have 16 could be written as 2 to the 4th power. Okay, so there's my 16. Okay, now it still has this 3/2 power on it. So I'm going to stick that on there. Now this 4, of course, can be written as 2 squared. So that's my 4. And it still has this 1/2 power on there. And then 32. 32 is 2 to the 5th power. And it's still going to have this power of 2/5. All right, and so now we have all base 2. A power to a power you multiply, so I'm going to do that in all of these cases. So let's see, 4 times 3/2, that would be, so I'm going to have 2 to the, that would be 12/2, which would be 6. Maybe I better show it. So that would be 12/2, and then times, and this would be like 2/2, all right? Because I'm doing 2 times 1 and 1 times 2. I said 2/2, but I put 2/1. Silly Mr. Burton. All right, and then down here in the denominator, I have 2 to the 10/2 power. 5 times 2 is 10. Why do I keep doing that? It's 10/5. That's what I meant to say. Okay, 10/5. So simplifying all this will give me 2 to the 6th power times 2 to the 1 power, if you will, over 2 to the 2nd. All right, I just simplified all these. Now, up here in the numerator, we know that 2 to the 6th power times 2 to the 1 power. I didn't really have to put the 1, but this is going to make 2 to the 7th power. So I have 2 to the 7th power over 2 squared. So if I subtract, I'm going to get 2 to the 5th power. Now, this is on the chart. So we know that 2 to the 5th power is 32. And that will be the final answer. All right, so that was number 9. Yeah. Okay, so number 10. Okay, all of these bases are the same. Okay, so I think I'll work with that. I mean, I have options because I could simplify all of these. You know what? I think I'll go ahead and simplify them all. All right, I'm seeing the 125. This is the struggle I'm having. I'm seeing the 125, and I know that 125 is a perfect cube. All right, the cube root of 125 is 5. I know that. So I'm very tempted to do this. This is what I'm tempted to do. First of all, so this is really the cube root of 125. Okay, the 1/3 power. And I just showed you that that was 5. So this really is just 5. And this, same thing, is also just 5. So that just leaves this. Now, remember how we learned to write this as a radical? And this is power over root. So looking at this guy, I feel like I should change colors for a second. Looking at this guy, this would be the same thing as the cube root of 125. All right? So the cube root of 125 raised to the 2nd power. Remember? Now the cube root of 125, like we just saw, is 5. So that will give us 5 squared. Now I could make this 25, but why not leave it 5 squared so that I can continue on with the same bases? All right, so this is, you know, if I was just doing this for fun, this is really how I would do it. So now I would go, oh look, they're all base 5, and these are like 5 to the 1 power. So when you multiply these together, I just add the exponent. So this would be 5 to the 3rd power, you know, over 5, you know, to the 1 power. And now you subtract. So this would be 5 squared, because 3 minus 1. And then that finally is 25. And that would be your final answer. So that's the way I would most comfortably do it. I'm going to show you one other way to do it. If you like the way I just did it, you know, you can probably just skip to another problem. But here's another way you might think about it. All right, here's an alternative way. Right from the beginning, all the bases are the same. So for the other problems, anytime the bases were the same, I went ahead and did something with the exponents. So another way to do this would be to go 125. All right, putting the numerator together, it should be 125 to the 2/3 plus, 2/3 plus 1/3 power. Get rid of that. Okay, over 125 to the 1/3 power. Because if you multiply and the bases are the same, you add the exponents. So that's what I'm doing, 2/3 plus 1/3. Now 2/3 plus 1/3 is 3/3, if you will. So this is going to make 125 to the 3/3 power. Now, obviously that's 1, okay? But there's almost no point in changing it to a 1 right now, because I would just have to change it back to thirds anyway, so I could do the next step. Because the next step, again, the bases are the same, so you can subtract the exponents. So this would be the same as 125 to the 3/3 minus 1/3 power. 3/3 minus 1/3 is 2/3, because 3 minus 1 is 2. So this would be the same thing as 125 to the 2/3 power. Now, I could simplify this by using this deal once again. Basically, we're back to here now. Power over root. So this would be the same thing as the cube root of 125. All right, that's the root. and then raised to the second power. All right, I feel like I need more space. There I go. So of course the cube root of 125 is 5. So I have 5 squared, which is 25. So that is the other way to do it. Either way, I'm going to get 25 for the final answer. So you decide which way you feel most comfortable with. This is the way that I probably would have done, but this way works also. Either way, you get 25. All right, that's it for number 10. Let me clean this up and get ready for number 11. All right, number 11. The bases are the same, so we can go ahead and subtract these exponents. Now be careful. I have to do 1/2 minus negative 3 over 2. Please remember that when you subtract a negative number, you add. So I'm getting ready to do 1/2 minus negative 3 over 2. But please understand that that's the same thing as 1/2 plus 3 over 2. Okay, so when I do this problem, I'm going to subtract, but so I'm going to wind up with 12 to the 1/2 plus 3 over 2 power. So that's going to give me 12 to the, let's see, 1/2 plus 3 over 2. Well, 1 plus 3 is 4, so that's 4 over 2. All right, well, that is 4 over 2 is 2. So that's 12 squared. All right, and that is 144. So that should be your answer, number 11. Let's take a look at number 12. Let's see. Inside of here, we have the same power. So that means we can go ahead and multiply these bases. So that is going to give me 40 to the 1/4 power. Now, I still got this negative 4 power out here. A power to a power you multiply. 1/4 times negative 4 is negative 1. So this will just be 40 to the negative 1 power. All right, I'm getting negative 1 because this is like negative 4 over 1. So negative 1 times negative 4 is negative 4. 4 times 1 is 4. All right, so that's where I'm getting negative 1 from. All right, of course, if something has a negative exponent, that means it is on the wrong side of the fraction line. So this is going to have to be dropped to the other side of this invisible fraction. Is this a symbol for female or something like that? Anyways, this is going to drop down and become 1 over 40. So that should be your answer to number 12.